Hello, in this video I'm going to look at the distance formula. So previously we looked at essentially how to plot ordered pairs and how we can write points, like as if you have like p x1 comma y1, and then you can look at another point, call it q, and maybe like instead of using we'll just use x2 and y2 respectively. So essentially our goal will be to find the distance from any set of 2 points, and we said that we could use the Pythagorean theorem. So if we go ahead and we use the Pythagorean theorem, then in this case we might say, okay, well, if I arbitrarily have a point from here to here, I can essentially just draw a right triangle that gives me that we have a distance from here to there, and we just want to find that distance, right? Okay, let me get rid of that. But the main point is that basically that you're forming a line from those set of 2 points. So if, for example, like this was the point P, and this was the point Q, then all that I need to do is essentially just find, what the distances are respectively for, so for, our x1, y1, and then the x2, y2. Now, of course, how do we do that? Well, we need to look for the distance from x1 to x2. And that's actually not too bad, because in actuality, the way of which that we can think of it is if we have an interval line and we have the ordered pair x1, or the component x1 and x2, we just want to know the distance from these two. Well, the distance that you would have for x1 and x2 has to be basically x1 minus x2, but the absolute value. And similarly, you have x2 minus x1, because whichever way that you look at it, whether you're going from x1 to x2 or the other way around, it's still the same distance, right? But you want to make sure that it's positive. So in that case, we know that the base has distance x1, x2. Okay, so if you want to put right here that the base has to be x2 minus x1, that's what we can do. But then what would the side where we have from y2 to y1 be? Well, similarly, that's going to be basically y2 minus y1, and then the absolute value. So how do we find the distance formula? Well, basically, because a squared plus b squared equals to c squared, that means that you're going to have y2 minus y1 squared plus x2 minus x1, that's going to be squared, and that's going to be equal to the hypotenuse in either case. So we could call this, why don't we call this c for now, right? So, because in either case, we know that c has to be squared. So what we'll do next, we have to take the square root, right? So we take the square root, and basically this gives us the following formula. It tells us that c is equal to the square root of the absolute value of y2 minus y1 squared plus x2 minus x1, and that's going to be squared. So now we have a formula in either case for distance from P to Q. Now, we'll go ahead and write this in a more formal sense that, that the distance from, so the distance from P to Q, it's given by the equation. Okay, so since we have that this is absolute and it's squared, we can actually get rid of the absolutes. So we have y2 minus y1, that's going to be squared, and that's going to be plus Well, we have that that's going to be x2 minus x1 squared, and then we'll just extend that. So here is actually our equation, right? We have that this is the equation for the distance from P to Q. So in either case, let's just move that a little bit down over here. And that's going to be our formula, right? Okay, well, what if I wanted to try that out, though, with any set of 2 points, actually? And we can do that, right? You know, because, like, if we have any set of 2 points, then we can always find that distance, respectively. So, for example, if we have that we have the ordered pair P, and it's going to be 3, negative 5, and then we have another point, Q, and this is not equal, but let's say, for example, that we use the ordered pair negative 2, 8, right? So if I want to find the distance of this, then in that case, all that I need to do is just say, okay, well, we can label each of these respectively as x2, actually this would be y1, right? y1, and then x2, y2. Now it actually doesn't matter the order of which that we label these, just as long as there's, you know, some consistency in either case. So let's go ahead and try to solve this then. And we'll just say that, okay, well, we have that the distance from P to Q is equal to the square root of, well, we'll do parentheses, 8 minus 5, and that's going to be squared, plus negative 2 minus 3 squared, that should be minus. Actually, yeah, let's just get rid of this. I think it's just an extra. So that should be minus 3, and that's going to be squared. And then we'll just extend that. Okay. Now, in either case, what we do have is that this is going to be negative 5, and then you have that that's going to be 13. So this is 13 squared plus negative 5 squared, and this equals to, well, 13 times 13 is 169 plus 25, and what we'll get is approximately, or exactly, the square root of 194. Now, typically, you may want to find, you know, like, what is the breakdown of 194, or maybe you want an approximation, for example, because I know that essentially the square root of 144 is definitely going to be less than the square root of 194. But then I know that, for example, that, let's see, 196 actually. The square root of 196, well, I know that that's basically going to tell me that the approximation is somewhere between 12 and 14. Now, if we go ahead and I use my calculator to figure out, like, what's the square root of 194, I'll actually get 13.93. So this is going to be the distance from, you know, P to Q in either case. Now, if I wanted to, let's say, for example, have you, say, for example, try finding the distance from any set of 2 points, then, you know, we can do that, of course. So how about you look at the ordered pair P, and we'll say that that's going to be negative 2, 1, and we'll look at Q, where the ordered pair is 3, 4. Now, note that if you find the distance of Q to P, this is the same thing as the distance from P to Q. So that goes back to, it doesn't matter the order of which that we choose these. Now in either case, if you go ahead and you calculate the distance from P to Q, using the distance formula. You know, so I'll go ahead and just write down the distance formula again, just so that we have it. So y2 minus y1 squared plus x2 minus x1 squared. And then this would be, this would be approximately 5.83. So I leave it to you to solve for how do you get the distance from here. Now, some motivation in terms of like, where would this be useful? Well, for the most part, one many aspect is that, like if you're taking trigonometry or even calculus and so on, we typically might use this for, things like navigation or even physics. Like if you have that a car is moving north and another car is moving east and it forms a right triangle, then you can talk about the distances that are between those two objects in either case. But you could also say that, like if, for example, there's a Coast Guard emergency, then you have that maybe there's a signal that happened over here, and then there's another signal that happened over here, and then this is your base of operations. And in any case, you can try to determine which one is closer if you're trying to make a choice, I suppose. But, like things like GPS, that sort of makes it, in a sense, kind of like, well, do we really need to find the distance this way? No, I don't know, maybe not, but, in either case, this at least gives you an idea of, like, where would you actually use distance formula in the real world. And, a lot of things that come to mind are things like navigation or even like air traffic controlling in either case, because you can base models on things like that.